Hello, and welcome to today's notes on graphing parabolas. So this is where things start to get a little bit different from Algebra 1, and so things therefore start to get a little bit more difficult. So what we have been talking about so far and quadratics that we have been seeing so far have typically been in one type of form, and that is called standard form, where you have your a x squared plus bx plus c, where you have those three terms, and we haven't seen it so much in other forms, but there are other forms of equations for parabolas, including intercept form and vertex form. Now, what we're going to focus on today is vertex form. Now, in the previous lesson, you've learned how to change your parabola or equation, quadratic equation, from standard form to vertex form. Vertex form is actually very useful when plotting and graphing parabolas. So typically we like to, when we're trying to do this algebraically, we try to get it into vertex form. It's just easier to graph that way. Vertex form, I know that the formula is actually down here, but vertex form is y equals a, and then parentheses x minus h squared plus k. Now, all those letters, you're like, what the heck is all of that mean? But basically, why this is called vertex form is because it actually contains your vertex. Your vertex is actually just h comma k. So when it's in vertex form, you actually are already given the vertex of the parabola. The axis of symmetry is a line, it's an invisible line that basically splits your quadratic or your parabola in half. So I have a visual down here. So you can see that this is a parabola, and there's a lot of extra stuff on here that you don't need to know anymore. But this is a parabola. As you can see here, this is a parabola. So the axis of symmetry will run perpendicular to it, and it will slice through the parabola right through the middle. Now, why that's important is because it's important to understand that parabolas are symmetrical, because when you go to plot points in a graph, you will know that there'll be a point matching it exactly on the other side. So when graphing, it makes things a little bit easier when you know that there are matching points on either side of the parabola. So it is an x equals line, and because it's a vertical line, it's an x equals line. So basically, your axis of symmetry will be x equals whatever the h value is. The same h value that's right here of the vertex, the equation for the axis of symmetry would be x equals h. Now, parabolas can be up and parabolas can be down. You should have already realized that by now, and hopefully you've caught on that if the parabola or the x squared is negative, then it would be upside down, and if it was positive, then it would be if it was positive, then it'd be facing up. And that comes from the a. So if your a is positive, meaning it's greater than 0, then it will be going up. I should just put an up arrow for a is greater than 0. And it will be going down or facing down if your a is less than 0. We'll go over all this multiple times, but just to sort of get a base here, your a determines whether it's going up or down. Also, the a determines whether or not it's going to be thinner or wider or normal. And again, we've talked about this before. That number that's out front, this is what we've seen when we have looked at transformations. So when we look at parabolas, this should look familiar right here, and I'm speaking of this. When we were using transformations of parabolas, essentially that was it. And there's a square that's supposed to be there. This was the the form that the equation was in when we were doing transformations. So this number right here was your a, and if your a was negative, then it would be upside down. So when we look at this, this is supposed to be a number line. Pretend that this number line is 0, and then 1, and -1, just for purposes. But basically, if your a value is between -1 and 1, if your a value is in here, it's going to be wider. And then at 1, right here, it'll be normal, and -1, it'll be normal sized. And then if it is greater than 1 or -1, then this would be thinner. So anytime your a value, and this is all about a, when a is between 0 or -1 and 1, then the parabola is wider than normal. If it is 1 or -1, then it is normal width. And then if it is greater than 1 or -1, then it is thinner. Just all things that you'll just pick up on. The more that we do this, that you'll pick up on this. So again, the axis of symmetry is a line that goes through the vertex, the weird V, goes through the vertex and is the middle of the parabola. Now, vertex, we already talked about vertex up there. I'm not going to write anything there. But everything you need to know really is right here. I've already sort of summed it up for you right here. One thing that you need to note that is when you're trying to find the vertex, notice how in the formula there's a minus sign there. So you got to be careful when you are trying to look at the equation and look at the vertex, because of this minus sign that's right here. Whatever goes in for h here is actually going to be the opposite of what is right here. Because what is right here has the negative incorporated with it, we want to remove the negative so the signs change. So whatever's here, it's actually opposite, and then k just comes down. So when you're looking at the equation and you're trying to find the vertex, just remember that this is opposite of what it should be. And I'll remind you later. So when it comes time to graphing, yeah, we can totally just put these in our graphing calculator, find that, but we have to be able to do this stuff algebraically as well. And before we did the fun part, really not really fun part, but putting in our graphing calculator, the easier part, and then just graphing it. Now we're going to get a little bit more precise. So here are some basic equations. Now this is in standard form. So this is your ax squared plus b plus c. But what we notice with these is there is no b and there is no c. If the equation looks like this, then it's not necessary to put it into vertex form. If you just have an a, it's not necessary to put it in vertex form, because what this tells you, if there is no b and there's no c, no b, no c, you know that the vertex is going to be the origin. It's going to be at 0, 0. If there's no b or c, the parabola is going to start at 0, 0. So I can already put that my vertex is 0, 0. So when I go to plot this on a graph, 0, 0, there's my point. Okay, my axis is symmetry because it's just x equals this value right here. My axis of symmetry, you can just put a of s is going to be x equals 0. Should be the same as the x point in your vertex. Okay. The other thing that you're going to, and so we represent the axis of symmetry. It's going to be kind of hard to see, but basically it's a dashed line that runs through the middle of the parabola. Because our a is positive, this is going to be facing up. Because it's between 0 or -1 and 1, the a is 1/12, so it's like 0.0 something. So it's between -1 and 1. we know that this is going to be very wide. Okay, so the only thing that we can do here really is to plug in points and try to find the answer. We'll use the axis of symmetry. So I'm just going to plug in a point, something that I know will be able to be, because I have 1/12, I want it to be divided by 12. So I'm going to use 6, because I know that when I plug in 6 squared, that's 36. And then you have times 1/12. Well, 36 times 1/12 is 3. So if I plug in 6 for x, I get 3. Okay, I plugged in 6, did the math, plugged in 6 for x, and then I got y equals 3. So I know I have a point at 6, 3. So I can go to 6 and 3. So you can see this is a pretty wide parabola. Now, I don't need to put another point in, because technically you need 3 points to graph a parabola. So, but I don't have to put in another point, because I know that I have my axis of symmetry right here, that I will have a matching point on the other side. So I know that this is 6, 3. I know that I will have one at negative 6 and 3 as well. So there'll be a matching point there, because parabolas are symmetrical. And so now, that's a terrible drawing there. There you go. And so I have a parabola. And so you can see that how much wider it is. It's wider than normal, because the 1/12, that's my A. Now, I'm not going to do 2, but it's the same concept that you would do in number 1. The only difference is your A is negative, so this parabola would go down. Now, what if I didn't know the equation? Could you come up with the equation? So here's an example where it says write a parabola, equation of a parabola in vertex form with a vertex at the origin, and it goes through the point 1, 4. So they give you some information here, and they ask you to write the equation. Well, let's start out with our basic equation. Y equals a x minus h squared plus k. So there's our basic equation. Now, a couple things that we know. It says that the vertex is at the origin. So, well, that tells us that our vertex, our h, and our k are 0. So I can write this as a equals a x minus 0. Or do I need to put x minus 0? No, not really. So I have x squared. And then do I need to put plus 0 in the end? No, I don't. But you would if you were, and we'll do this in a few minutes here. But now, here's the other part. So there information that they give us. Well, it says that now it also goes through the point 1, 4. Well, what we can do is we can use the x and y in that point and substitute it for the x and the y here, because our goal is, and what we need to do is we need to find a. So let's plug this in. Y is 4, and then we have a, and I have x is 1 squared, and then we can solve for a. Well, 1 squared is 1, so I just have 1 times a, or a equals 4. So now, when we go to write our final equation, y equals a is 4, parentheses, x. Now, our vertex is 0, so again, essentially you're just going to be writing this equation now with the a in there, and so that would be it. Technically, you don't need the parentheses, so technically it could just be 4x squared. Let's bring everything closer together here. And so technically that would be your answer. I know this is a weird one that it's going through the origin because everything's zeros, but we'll show you an example of a different one here in a minute. So now let's look at what like a normal parabola. Let's look at like a one that's like a regular one. So here's an example of a parabola or an equation that's more of one that you might see like on a quiz or a test. what we need to do is we need to change this into a vertex form. In order to graph this algebraically, we want to get in the practice of putting it into vertex form. It's just easier to work with. So I'm going to put this into vertex form, which means I need to move this -8 over, leaving a space there. So x squared plus 2x with a space equals +8. This should not be anything new. All I'm doing is what you did in the previous lesson, which is changing this to vertex form. We added 8 to the other side. And so what you needed to do, remember, is you need to take half of your b and square it. Half of 2 is 1. 1 squared is 1. So we add 1. Now remember, we can't add 1 to one side and not the other, so we add it over here as well. What this does is it gives us a perfect quadratic in that the same number multiplies to be the b and the a. In this case, what multiplies to be 1 and adds to be 2? Well, it's 1 and 1. So what we get is x plus 1 squared equals 9. And then we just move the 9 back over to this side. So we get x plus 1 squared minus 9 equals 0. And so now we have changed it into vertex form. And so now we have our vertex. Just remember, so let me change colors here, that the vertex, the x value here, is actually opposite of what it should be. Remember that the formula has a negative in it, so whatever is there should be opposite. So our vertex is not 1, -9, it's actually -1, -9. Your axis of symmetry, or A of S, is the x value of that vertex. X equals the x value of that vertex. And then we want to find another point. Now our A, since there's nothing out here for A, we know that our A is 1. We know it's going to face up. We know it's going to be normal size, right? So we can start with our vertex at -1, -9, way down here, okay? A couple other things to note here, and actually I'll tell you here in a second. We have our axis of symmetry. I'm going to use a highlighter just because it's just easier to see. And I'm going to shrink it though, just so it's not so big. So our axis of symmetry runs perpendicular or up and down. There's our axis of symmetry. And then one thing that we wanted to note here is, remember what we learned back when we know the y-intercept of this parabola. Okay, remember that this number right here is your y-intercept. So we can say our y-intercept is y, or not to say y, but it's -8. So I can go here and say, okay, -8 is my y-intercept. Now, because of the rules of symmetry with parabolas, I know that this is symmetrical. So if I have 1 right here, then I will have a matching 1 right there. And all you need are 3 points to graph this parabola. And so you just go something like this. You could also take this a step further and find the x-intercepts as well. If you wanted to do that, I think it's -4, -2, so -4 and +2, something like that. But yeah, that's all you're doing. Vertex, axis, symmetry. Same thing goes with number 5. Number 5 ends up being the same thing. We'll go back here, number 5, and if we have some time here. But what we want to do here with number 6 is now write an equation. So this is an example just like up on the previous page where they don't give us the equation, we have to write the equation, and then we're going to graph it. So we do know that it does have x-intercepts of -7 and -1. We need to write the equation for this line, and it passes through the point 1, 1. Now, when it gives you the x-intercepts, there is another way that you can write this. So we can use our graphing calculator here to find these points here. Because the x-intercept, so we have x equals -7 and x equals -1, what we can do is we can put this into factored form by working backwards. Whenever it gives us the x-intercepts of -7 and -1, we can actually just work backwards and say, okay, well, if we're working backwards, if we're starting with our solutions and working backwards and we need to find the equation, when we were doing equations, so let's just say, I had x, squared plus 4x minus 8. That's not going to work. Let's do this one up here. X plus 2 plus 2x. And so when you found out what multiplied to B or C and added to B or B, what multiplies to be -8 and adds to be 2, you would say that that's 4 and -2. 4 and -2 add to be 2, and 4 times -2 is -8. So we'd write that as x plus 4 and x minus 2. And then what you did is you set these equal to 0. So you had x plus 4 equals 0, x minus 2 equals 0. And so you would subtract this over and get x minus 4, and you would get x equals 2. And that's how you got your x-intercepts. Well, now we're going this way and we're working backwards. So now that we have our x-intercepts and we know that what's here in the factors is opposite, we can put it in factored form. So if I know my solution is x equals -7, then I know the factored form would be x plus 7. And if the solution is x equals -1, then I know the factored form would be x plus 1. And so we have an equation. And this brings us to the second type, the other type of ways that we can write a quadratic equation. This is called intercept form. Intercept form is what we see here, only with an a in front. Now we don't know what a is, so we have to find a. And how we find a, let me make this bigger again. How we find a is to use the point that it gives us, 1, 1, and plug it in. 1, 1 means that x is 1 and y is 1, so we can plug those into the x's and y's. If y is 1 and x is 1, then we can find out what a is. 1 plus 7 is 8. 1 plus 1 is 2. So I have 2 times 2, which is 16. So 1 equals a times 16, or 16a, divided by 16. So a is 1/16. So now I can write this equation in intercept form by writing 1/16 as my a, and then x plus 7 and x plus 1. So what we have seen here is that you can write this into vertex form, which is what that looks like there in the red highlighting. Vertex form, if you're given the vertex or you know the vertex, you can write it in vertex form. If you're given the intercepts like you were down here, you can put it in intercept form, which this is intercept form, right? Let me highlight it right here, where you have the intercepts and you just put it into intercept form and find a. We will definitely get some more practice with this, especially what we did in number 6. But that is graphing parabolas. We do have to graph this. Actually, I forgot to graph this. Okay, so we do have an intercepts at -7 and -1. So -7, -1. It does also say that it passes through the point 1, 1 right here. It's interesting. -7, -1, and it passes through 1, 1. This is giving me a really wide graph. One thing that you need to know also with the axis of symmetry is that it cuts in the middle. So we want to find the middle. You just go right between your x-intercepts. Looks like it's right here. Their axis of symmetry. So I will have another point. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We'll have another point right there. And then the vertex, we would then have to find the vertex, which you could multiply that out. I'm not going to do that at this point here because you're not going to actually have to graph this type of problem on an actual test. But the vertex is right in here. So that is graphing parabolas. Again, that last part probably, it might be a little more confusing now that I look back on it, but we will go over again number 6 in class, that type of problem. Most of your problems, I'll tell you right now, will look like the first half of this lesson. So thanks. Hope this helps.